Welcome. This video introduces CStrings and talks about how strings and arrays are related. So C++ added a bunch of new features to C, and one of the big ones was this idea of objects, the fact that we can have a collection of data and behaviors that are associated with that data. So a string that we've been dealing with in C++ is one of these objects. It has some data, a bunch of characters, and it has some behaviors, things we can ask it to do like return the length, find the location of something inside the string, erase certain characters. C does not have objects. In C, if we want to create a string, we can't use this notion of an object, so the way that C handles strings is as arrays of characters. So name is an array of characters, and we initialize it with the string literal Joe. This would be considered a C string, a character array. And they're treated slightly differently than normal arrays. Basically, there's some special tools. We're allowed to initialize them with string literals. We can also print them like this. So I can see out hello and then Joe. Normally, trying to print an array would just print the memory address, but character arrays are treated special. But if we run this code and go look at the debugger, something weird happens. This name variable shows me that it's storing JOE \0 and that its type is a array of 4 characters. So what's going on? Where'd this extra chunk come from? Well, every C string is supposed to end with a 0, with \0 is the way to indicate the special character 0. So if I'm storing my name Andrew in a C string, I'd need room for the 6 characters plus this extra 7th character, the 0 character, to indicate that it's done. And why do we need this? Well, remember arrays we have to create with a constant size. So say I want to read something in from the keyboard, I have to create the array and have enough space there to handle however much input I'm going to get. So usually we have to do something like allocate 100 characters in an array, read in from the input whatever I'm going to read in and hope that I don't go over 100 characters or bad things are going to happen. And then I'm going to have a bunch of extra unused character slots in this array. So to indicate which ones we're using and which ones we're not, we go ahead and just use everything from 0 up to however many characters we need, and then we put the 0 null character in to indicate that, okay, everything after here is garbage. Don't worry about this stuff. Now to be real clear, that 0 character is the null character. It's got the numeric value 0, and as a character literal we say it's \0 to differentiate between the digit 0, the character 0, which is ASCII code 48. Now, if a C string doesn't have that character, the assumption is going to be that it doesn't stop. If I have a C string and I build it so it looks like this and there's not that trailing null character, most code that expects this to behave like a C string is just going to start reading and reading and reading and reading and keep going until it hits a null character just by chance. And who knows how far in memory it's going to go. Similarly, if I give most code that's designed to work with a C string this character array, it would assume that this represents the word and. Right? And that this is all garbage. As soon as it sees that first null character, it would assume, oh, we're done here. There's only 3 real characters in this string. So most code that is designed to work with C-style strings basically works something like this. If I was going to write a function that takes in a C string, an array of characters, and prints it out with spaces between each character, like hello down here, I wouldn't bother taking in the length. Right? What I'd do is I would just start with the first character, number 0, and keep going until I hit a null character. So while the current character isn't the null character, keep going, print out the character in a space. and the length is implicitly determined by wherever the heck that null character is. Which brings up kind of a weird point. How long is this C string? It's got room for 100 characters. It's initialized with Andrew. Right, so the array itself is 100 elements long. The length of the C string, the logical length, would be 6 characters. And if you asked a function that was designed to look at C strings, hey, how long is this? They would give you that answer. But to store those 6 characters, we actually need 7 elements in this 100 element array, because we have to store the 6 real characters plus that null. Now there's a whole set of CString library functions. If you're working in C, you include string.h. If you're working in C++, you include the library CString. And it has things for doing all the same functions that we can do with C++ strings. I can look for a substring, so that's like our find. I can copy strings. I can ask how long strings are. The one thing I can't super easily do is erase parts of a string and change its length. Right? I can copy pieces out of it and I could replace what's in there, but I can't necessarily resize this array very easily. Now, you don't have to memorize these string functions. There are times when one of them ends up being a little easier to use than a C++ string function, so every now and then you'll see them in C++ code. But it's important to realize that they're there, and it's this whole other world for dealing with strings in this different way as character arrays instead of string objects. Now, C++ strings, right, much more friendly to use. We can ask them for their own length. We don't have to worry about this null termination. They may be, they may not be behind the scenes. And we can still access them like an array. Right, behind the scenes, they probably are stored with some kind of array, and they allow us to index into a particular string just like we would with a C-style string, a character array, or any other array. Which means that if we've got a string, we can loop through using either .at. So I'm going to start counting from 0, keep going while we're less than the length, so I don't have to rely on that null character to determine the end. I can ask this string, hey, what's your length? And I don't want to actually hit it, but we'll go up to length minus 1 and print out each character like that. We can also access using the array subscript. And if we want to modify something, then we definitely have to use this version. The saying text.at will give me the character at that location, but won't allow me to modify it. Saying text sub I, instead of just printing this, I could say text sub I equals something new to change each character. And this particular listing goes backwards through the string. We start at the length minus 1. Right? If there's 10 characters, then the last character is number 9. We count down until we get to 0. And that'll print, take hello there, and print it backwards, start with the E and work its way backwards. We're going to take a quick look at a real program looping through a string. So this program is going to convert hex numbers to decimal. So hopefully you remember that hex numbers, we have digits of 0 through 9, and then A, B, C, D, E, F, representing 10 through 15. And the place, each place has a value 16 times larger than the last. So we've got the 1s, the 16s, the 256s, the 4096s. And so our goal is to take something like 12E9 and turn it into the base 10 equivalent, 4841. So to do this, we need to access each of these digits, so we need to loop through them. We need to figure out what value it represents, so this would be 1, 2, 14, and 9. We need to make sure we know which place we're in, and we're actually going to work backwards because I know the last character is the 1s, and then the next one's going to be the 16s and the 256s, so I can just keep multiplying by 16 to get the next column. And we need to build up the total as we go. So here, let's go grab that, is the hex final. And you can download the code sample from the class files drive and go through it yourself. So we read in the string. We have the place value that starts as 1, and every time we go through the loop, we're going to multiply that by 16 to figure out the next place value to go from the 1s, the 16s, the 256s. We have a total to keep track of the value. And now we're going to work backwards through the string. So we get the length of the string, we subtract 1 from that to find the last character, we count down until we hit 0. We get the current character, so the first character is going to be something like the 9, because we're going backwards through the string. And we convert it to uppercase. Don't necessarily have to do that, but that way if we type in like lowercase e, we'll still handle it correctly. And now we're going to figure out the value of the digit. So for something 0 through 9, if it's in that range of characters, well, we'll subtract the ASCII code for 0 from it. All right, so if I have something like the character 4, that's 52. If I subtract the ASCII code for 0, 48 from it, 52 minus 48, that gives me 4, right? The numeric value for that character. If it's A through F, then we'll subtract it from A, and that way A is 0, B is 1, C is 2, etc. But then we'll add 10 back. So that way A will be 10, B will be 11, C will be 12. All right, so that'll handle the letters that are potential in hex, and anything else will kill the program and print out an error message. So once we know the value of the digit, 0 through 15, and we have the place value that we've been building up, that starts as 1, we'll multiply those two and add that to the total. And so that would be like 9 times 1, and the next time it'll be 14 times 16, next time it'd be 2 times 256. And we'll increment the total with the current place as value, and then we'll increase the place value for the next column. Once we're done going through the whole string, we'll print out the total. And we can give it a quick try. And we'll try 1 to E9. It tells me 4,841.